All right, welcome to our lesson here. We're going to go over scatter plots, and so hopefully a lot of this is review. And so what I have here is a picture of some different scatter plots, and you have to figure out which one would show the relationship between a person's height, how tall they are, assuming they're an adult, and their IQ score. So generally on these lessons, I'd like you to pause the video and try them first before watching the solution. Do that here. And then I'll go over the answer. All right, so the trick on this one is a scatter plot. Kind of the point of it is it shows how the two variables are related. And you can sort of have, roughly there's three different ones. You can have a negative correlation, which is basically would say that as your height goes up, your IQ goes down, which wouldn't make sense here. Okay, and then all that's different between these two is this is a stronger correlation. They're both negative, but this would be a stronger one. This would be a little bit weaker. Okay, you could have no correlation. So I guess I could mark this. This is negative correlation. This one is no correlation. All right, and that just basically says as our height goes up along the x-axis, it does not affect our IQ score. So I think that would be the right one here. My hypothesis would be that there would be no relationship between your height and your IQ. Okay, and ultimately that'd be the point of a scatter plot. Like if we really wanted to know how these were related, we could plot people's data and then figure out what does it look like. Right, but I'm decently confident height and IQ would be no correlation. Okay, and then the last type over here, these are called positive correlations. And that's just as one goes up. So as height goes up, the IQ goes up, right? That would be a positive correlation. Again, I don't think that's the case here, but that's what it means to be positive. Okay, and again, we can draw, these are called lines of best fit. And the tighter the points are to the line, the stronger the correlation it is. All right, so that's what we're going to do is review the scatter plots. Really the point is anytime you have two variables, want to figure out how they're related, you can plot the data and see what it looks like. Okay, so we already talked about this, but one more time, what correlation is, it's just a relationship between 2 points. I guess it'd be 2 quantities would maybe be a better way to say this, like the x and the y, but it could be like your height and your shoe size. It could be how much you study and what you score on the test, right? It's just a relationship between two quantities. And here are just, some, basically there's 2 parts to it. It's a positive or negative slope, and then is it strong or weak correlation, right? The tighter it is to a line, the stronger it is. So probably the strongest correlation is this one over here because there would be the tightest to our line of best fit there. Okay, so this was actually a scatter plot from when I was working at 3M. They had me take the air that was in this sign. Like they made these street signs and they were trying to make them as bright as possible. So they had me measure the air in the sign and how bright it was in candle power. And so here's what I got. All right, so what type of correlation and what do we know? Pause the video, give it a shot. All right, so this would be an example of negative correlation because the line is going down. All right, and what it means, okay, so they might ask you this on the test. What it means as the angle air goes up, as it increases, starts at 0 and then gets bigger. As it increases, the brightness of our sign goes down. So the more air there is, the less bright the sign is. All right, and it's a pretty strong correlation because it falls pretty tight to this line. Another thing they might ask you about is what's shown up here. Okay, and this number is called the correlation coefficient. I think I've seen them ask that before. Correlation coefficient. Right, and that just basically tells you how strong the correlation is. Right, and so the closer it is to 1, the stronger the correlation is. All right, so here it's a pretty strong correlation. Okay, so back when I was teaching in the middle school, I tried to figure out what would predict how well a student would do on the MCA. So on this scatter plot, you see a student's test percentage, their average percent in class, right? And then what they got on, this was a practice MCA test. But anyways, you can see like this student here got about 95 on their test and about 850 on their practice MCA. So 3 questions for you. Try them, and then we'll go through the answers. All right, so what we've got here is a positive correlation again. That's a positive correlation. I guess I shouldn't have said again, but it's just a positive correlation. And then as basically we'd say the higher a student's test percentage, the better they did on the MCA. Right? So basically that they go up together. As test percentage goes up, practice MCA score also goes up. Positive correlation. You can see it's a little bit weaker, so this is that correlation coefficient again. And here it's not as close to 1, so it's not quite as strong as correlation as our previous picture, which makes sense, right? These ones are really tight to the line. Here they're not quite so tight. It is a positive correlation, but it's not very strong, right? You could almost argue that this is no correlation, but based on the line of best fit here, it is, positive correlation. Okay, so another thing is they might ask about like the equation for this line. So basically we could do a y equals mx plus b equation by just doing a little bit of math. So we could do y equals mx plus b. Okay, so we'd start with the slope, and the slope you sort of need 2 points. Like there's that slope formula that says subtract the y's on top, subtract the x's on bottom. Okay, and so I would try to find 2 points from the line. Okay, they don't have to be these dots, just on the line. So what I would do is do like 80, like a test score of 80, and then just kind of try to guesstimate this. So this point I'm going to say is about 80 and about 852. Okay, and then I would go over like 10 units to make it simple or something like that. So I'm going to do at 90, and that's about 90 and 856 roughly. Okay, so now we can do our slope by just subtracting the y's on top. So the y's would be 856 minus 852. Okay, and then subtract the x's in the same order. So I do 90 minus 80 on the bottom. Okay, so our slope would be about 4 over 10, which you could leave it that way or write it as 4/10. So basically, as our test percentage went up by, our MCA practice score went up by about 4. Okay, so if I wrote the equation, or the start of the equation at least, the slope would be 0.4. And then to find B here, there's a couple routes. Like B would be the y-intercept, which would represent if you had a 0 in class as your test percentage, what would we predict your MCA score to be? And so you can actually take one of these points in the slope and write it in point slope and convert, or you can put in one of these points for x and y in here and solve it for b. All right, so based on how I did it earlier in the year, I'm going to do point slope form and convert. So remember, point slope form just goes y minus y1 equals the slope, and then x minus x1. So I'm going to pick this point right here and make that x1, y1. So I'm going to do y variable minus y1 equals the slope of 0.4 times x minus x1, which is 90. And then I just got to clean it up. So I'm going to distribute this in. So of y minus 856 equals 0.4x, and then 0.4 times 90, I think, is 36, I think. Okay, and then from there, I'm going to add 856 to both sides. So I get y equals 0.4x, and then I think that's going to be plus 820. So it's kind of an indirect way, but now we found B, right? So that's sort of saying if you had a test percentage of 0, we'd predict MCA score of about 820, which is actually a pretty reasonable guess. So our slope is 0.4 and our y-intercept is 820. So thus we would have the equation like that. All right, so the correlation coefficient is basically this number. And I don't think you have to calculate it on the MCA, but basically the closer it is to 1, the stronger the relationship. So basically we would say that this is a weak positive correlation. Okay, and we know it's weak because that correlation number is not very. Okay, last thing I'm going to have you look at here is one more, what type of correlation, what we can conclude. And I probably, well, I'm not going to work on the line of best fit. Maybe I'll show some of that math here, but I would definitely, you might have to find slope and y-intercept here. So you could think about those also. Pause the video. Okay, so what type of correlation do we have? This is going to be a negative correlation. As time goes up, the percent of our iPod remaining battery is going down. And so that's what we would write here as time increases, the amount of battery decreases. I guess I'd say that battery percent, but I don't have space there. So just a couple notes about if I was doing the equation. One thing would be, I would guess, even though it doesn't look like it here, the y-intercept should be about 100, right? Like if you start off after 0 hours of use, right, we should have about 100 battery life. So if I was actually writing the equation, I would have like y equals mx, and then my b should be 100. Okay, so just, I know my graph doesn't look like that, probably because my line's not exactly perfect there. But then for the slope again, I would try to find 2 points, and I try to space them out a decent amount, and I try to space them by something that's easy, like 5. So maybe if I do my x's as 2 and 7, then they'll be spaced apart by 5. So all I got to do is read off my line of best fit. So that's like 2 and 90. That's kind of a nice point. 7, that's also another nice point. 7 and 40. Okay, so again, if I needed my slope for this situation, I would just subtract the x's on top. So I'm going to do 90 minus 40. Sorry for the bad handwriting there. I do my x's, I'm going to do 2 minus 7. Because I did the 90 first, I got to do the 2 first when I do my x's. So that's going to come out to be 50 over negative 5. So that's negative 10. So basically, for every 1 hour, we lose about 10% of our battery. Okay, so our overall equation then, if I go back up here, I want to say my slope is negative 10, and my y-intercept, even though it's not right from this picture, it looks like it's about 110 in my picture. I'm just going to call it 100 just because I know that that's how much I should have. So maybe my line of best fit should have been, I could have the same slope, but it maybe should have been down here. Well, that doesn't look like it's through the middle. But anyways, you get the idea. And on the multiple choice, you just got to get in the ballpark if they're asking you about slope or y-intercept. Okay, so generally pick some points off the graph and you can find it that way. All right, that's all I got. Thanks for watching.